Yes, good. Welcome to the session. Welcome to this MethodsNet webinar. My name is Bastiaan Bruinsma, and I will today present this webinar on recent advances in quantitative text analysis. And the webinar is a little overview of what's been going on in this field. It also gives you an idea of what kind of things will also be offered on the summer school that will be organized later this year. What is going to be there. We're going to take an hour. Roughly depends how much time we can put in. So let me give an idea of what we're going to do. I first want to talk a little bit about the background. So what's the idea of text analysis? What do you need to know? Then I will tell you a little bit about what I will call traditional methods. And traditional in this way that if you follow a course on text analysis until say like 4 years ago, this is what they would teach you. And then I will talk a little bit about word embeddings, transformers, multilingual solutions, and I will talk a little bit about considerations. And these 3, 4, 5, and 6 are elements that are very new, they're advanced, and they're currently being developed. And that's where the main interest is. Yeah. So let's start a little bit with some background. What's been going on? So what's been going on in the last years basically is that text analysis is very, very rapidly growing and changing faster than ever. Each year and month, we've seen new methods. Each day, we have a new large language model. New data sets come out quicker than we can analyze them. And quantitative text analysis, and I would say especially quantitative, is becoming increasingly more convenient to perform. If you wanted to perform a quantitative text analysis as few as, say, 10 years ago, you often go to the trouble of actually getting the data, having to clean it manually. Your processors might not be good. Statistical software was sometimes hard to get. You had to buy it, it was expensive. And it's very easy to do right now. And one of the things that's been helping is that there has been increased transfer of methods from other fields. So quantitative text analysis and social sciences has profited a lot, for example, of the recent developments in computer science and other related fields. It's been coming up very soon. And the latest big hot things are word embeddings, transformers, and very, very, very large quantities of texts. This big data, that term which is being used and abused all the time. But where earlier the problem was that we had to find text, now the problem is that there is too much text, and we have to get rid of it once in a while. So the focus here is that given the high rate of change and developments, understanding quantitative text analysis, you should focus on understanding why things happen and what they mean, meaning that you better focus on principles over methods. The reason for this is that there are so many methods to choose from that it doesn't make an awful lot of sense to learn them all by heart. You'll find that by the time you learn them, you probably already are behind. It's way better to understand what's going on, why things are happening in your text, and what you actually want, and then find the method that fits with that. I will get back to that later on. So, a little bit of background. This background is rather general, so this is like the standard thing that goes for a lot of times also for things like qualitative text analysis. And one of the main things that you need to realize is that when we work with quantitative text analysis and we use a model, we use a technique, we've got to realize that no model is ever complete or correct. However, they can be useful. And I stole this quote from a Grimmer and Stewart article and also from a book called Text as Data, which I will come back to later, which has this. And the reason for that is that if we have a piece of text, say we have a government white paper, for example, we don't know how that text was generated or how it was written. We very rarely can go into the mind of the person that actually writes it and say, like, why did he or she choose that word? Yeah. Secondly, language is actually a very, very complex thing if you think about it. If you remember when you were like a very young child, it probably took a couple of years before you actually got the hang of language. Yeah, we even study it in school. It's not an easy thing, right? For a human, it's very easy to see a sentence like "time flies like an arrow and fruit flies like a banana." That flies has two completely different meanings. Yeah. Um, or a sentence like, if you aren't fired with enthusiasm, you will be fired with enthusiasm. Where the places where you put commas and how the word fired actually works, it is relevant. And another one, for example, like make peace, not war, versus make war, not peace, is a very nice example of what happened for a long time when we did something called the bag of words. Um, okay. When we did something called the bag of words, um, and where we sort of like saw this idea of the order of the sentence not being actually that relevant. Therefore, by definition, a model by definition fails to capture full language. So if we have a sentence like that, we always lose something when we put in the model. Yeah, so we get rid of this complexity. Um, and what we get back for that is the fact that we can actually run it and we get some simplicity out of there. So it can be useful. Yeah. And we can then use various methods of validations to figure out whether they actually work the way they do. So a couple of things that we assume when we have to deal with digital text. So say you have a piece of text, it's nowadays always digital, is that we have to assume that our text actually has information in it. Yeah? It represents some sort of opinion, a sentiment, salience of an issue, or something. The text is not meaningless. There is meaning in that text, and it has been encoded in these words, and we try to get back that meaning. That's what we try to do. Now, the second one is something that's currently being challenged. So for a long time, you would say that word order is roughly meaningless. Yeah? So this was known as the bag of words. And what happened is that we have a document and that we just basically do word counts. So if I have a sentence like, we can use a document feature matrix to say something about the characters of interest, then we just count each and every time each word occurs, and we make it into a data frame. Nowadays, and we'll go back to that later, with word embeddings, this is not necessary anymore. The reason we did it for a long time was because this was the only way to keep it computationally actually doable. And it turned out actually that it was actually quite good. Using a bag of words actually gave quite good results. Now, what we then did is that we used a document feature matrix to say something about the characters of interest. That's kind of what we showed. And this bag of words, like I said, basically challenged the idea that word order had any kind of point, was relevant in any way. So, for example, if you have a sentence like, this is not how language works, this is no a true assumption, nobody cares. Yeah. Versus something like, how language works, this is not true assumption is not. Yeah. So that's exactly the same sentence with a complete, it's a different order of words. But for the bag of words, it doesn't really matter. You just count the words. And this feels very wrong, but it worked actually very, very nicely. So what you do, you basically, you make a list. What you end up with is this. This is this data frequency matrix that I said. So say you have two texts. You have like on your rows, you have like all the unique words, and then you sort of count it. So here the word watch, for example, occurs 3 times. It's kind of like that. And one of the things you notice is that the word watch means 2 different things here. It refers both to the verb, to watch, and actually the object. But here we don't distinguish this. So this is one way where you see that we're losing information by putting it in a model. Yeah. And again, later on with these word embeddings, we actually get rid of this problem. But this is one of the things that's happening. So what you end up with is a long document with all your words and then basically counts. Yeah? And it's a very sparse matrix. But scholars have become very, very adept at writing software and techniques that are actually very, very good at this. Yeah? So this is what I do. And digital text, so for people that are going to work with it, digital text is quite awful to work with. If you work with quantitative text analysis, you very often have text already in a database. But if you don't, then you, for example, have to get it from a PDF file, then you're probably going to spend about 80% of your time on actually cleaning of the documents, getting it into a right state. And for example, here I've got a manifesto from the Green Party for the European elections a couple of years ago. And it looks really nice, and then you read it in, and it's a complete gibberish. Yeah. So you need to OCR it, you need to get it in a good form, etc. And all this cleaning bits is a lot of work quite often. This is also why I would also implore you that if you ever get a data set with text in it, always cite the persons that make it, because it's probably going to be a lot of work. This is another example where if you select it, you get gibberish. Moreover, you can select it in a nice line and it's two columns, which is a problem. So you need to also decide what you do. Very often in these documents, there's a big visual element. Yeah. So things are, for example, in red and green. We see here little tick marks. All these things disappear. Very often, even people decide to get rid of numbers, for example, because it's not very interesting. However, it might be very relevant if I, for example, refer to like 4% hurdles, or like we see here, like 8.15 billion. If that's a number that's being like constantly mentioned, you might want to figure out whether or not it's cleaning or not. Yeah? And you need to clean this all. Another thing is that I would always have to take encodings into account. What happens if you got a document, say, that's in German, or you have multiple documents and one of them happens to be in Bulgarian and is therefore in Cyrillic, and has different encodings, and suddenly it's all gibberish. If it's non-Latin scripts or too many text, etc. All these things are relevant. The reason I say this is that if you do text analysis, one of the things that people like to do is just take a data set and run something on it. However, like Grimmer and Stewart already noted in 2013 and later on also reiterated in the latest book, there is really no good substitute for taking the trouble to become familiar at least with the basic orthography and word usage of the body of text to be considered. So in practice, that means nothing beats just opening a couple of texts that you're dealing with. Even if you're dealing with 1,000 texts, just open 4 or 5 and have a look what's in there. Is it big? What kind of writing style is it? Is it what script is it? Just getting a grip of get an idea of the data you're working with. So you need to understand your data before you actually put in the method. Yeah, it's not the other way around. And this pre-processing is therefore one of the most time-consuming and difficult parts of the whole procedure. Quick and easy does not exist here. So if you do go to the text analysis, your pre-processing is probably going to take most of the time. Running the fancy method, that's the easy bit. Yeah, interpreting, visualizing might take time, but the method, what we focus on mostly here, is actually the easy bit. And the reason for that is that this pre-processing doesn't come with a checklist. They're not something that you should do and always should do. It depends on the case. Yeah, so it depends on whether or not you want to convert stuff to lowercase, or whether you want to remove numbers or punctuation or a white space or stop words, headers and footers or metadata. Yeah, that depends on you. And even more complicating than that is that whether you do this or not, and the order in which you do it, actually influences it. Yeah. So a very nice example was given in 2018 by Matt Jenny and Arthur Sperling, if I'm correct. And what they did is that they took quite a lot of party manifestos And they used, I think, Wordfish to sort of like scale them. And I wanted to know the most left and the most right party. And they basically did different kind of pre-processing steps, like the ones I mentioned here. And they indicate them with letters like punctuation, is P, or numbers. And then they put them in. And they did them in different orders, in all kinds of different orders. So 128 in total. And then they basically looked, given different pre-processing and the same method, they found completely different conclusions using exactly the same method. So the way that you pre-process basically changes your outcome in the end. Yeah? So it's not some random thing. Yeah, it really influences what's going on. And that's why if you do any analysis, you should always at least put in an appendix where you say like, this is how we pre-processed and why, and this is how we justify it. Yeah, and this is what we think the effect is going to be. You've got to prove that it's stable. Yeah, so keep that in mind. So if we want to do any text analysis things, so what do we do? Well, the first thing is that we actually select our text, and this is the actually harder than you think. You've got a problem, and you've got to figure out how I'm going to limit my text selection. What goes in, and what goes not in. Yeah. So basically, it's defining the corpus. Because again, if I put in more documents, for example, in a scaling algorithm, it might be that the rest of the files changes position. Word scores, for example, which I will touch upon in a minute, has that problem. Yeah. You need to convert this to electronic format, and then you have got to figure out what is it you want to measure. Yeah, are you interested in emotions? Are you interested in party positions? Are you interested in word choice? What is it you care about? And with that, you have to then define what your features are. Are you looking at individual words? Are you looking at longer phrases? Are you looking at tokens, which can also be like n-grams, like 2 words in a row, etc. And you care about dictionaries, which words occur. Then you convert this into a quantitative matrix, so your text goes into something that the computer can read. Then you run the model, and that's the bit the computer actually does. That's what R does, or Stata, or SPSS, or Python, what you want. It's a quick bit. And then you have to summarize and interpret. Yeah? So most of the focus, all these methods that we talk about, is just one little step. And it's mostly the easiest bit. So with that as a background, let's have a quick run over the traditional methods. So some traditional methods that we have are, for example, dictionaries, in which we have a list of keywords that we predefine or pre-select. And we just ask the computer to look at those words and count how often they occur in a text of interest. Yeah. And then we can sort of order these keys that we have in a dictionary into different categories and, measure something. And there are tons of dictionaries out there. There's emotion dictionaries out there. There are political orientation dictionaries out there. There are dictionaries out there to measure things like harassment, discrimination, etc. Tons of them. And it's basically just counting. Yeah? This is something that's very related to what's happening in qualitative text analysis, where you literally just code sentences. Yeah? It's an interesting thing. Dictionaries are still very popular for good reason, is that they're just simple to do. Yeah, but you need a very good code book. Yeah, but once you have it, it's actually not that hard. Then there are scaling methods. Now, scaling methods, basically what they do is they put your text on any kind of scale. Yeah. Say, for example, for purposes of example, something like a left-right scale, yeah, or a progressive conservative scale, or like a pro-EU, anti-EU scale, any kind of scale. And here are a couple of the more popular ones. One of the older ones is word scores, which basically takes it and puts it on a dimension that you put in the beginning. You decide what it is. Wordfish, which doesn't has just a single dimension and puts it on whatever it thinks is the main dimension. There's correspondence analysis, there's word-shell, there's class affinity, multidimensional scaling, all kinds of things that do roughly the same. Yeah, so they scale something. Yeah? And here, for example, you see word scores, already 20 years old right now, in which you basically have a couple of reference texts that you give a score. Then what the algorithm does, it looks at the words in those reference texts, looks at how often the word occurs in the text, multiplies that by the score that you gave it. So, for example, how conservative it is, and then it uses that to classify another set of texts, and that you can put that. Yeah, they call them your virgin text, and that's what it does. So it scales new documents based on scaling positions of the old documents. Very simple and very popular. Wordfish is another one in which you basically take a lot of documents that you have, and using item response theory, it basically scales it on one main underlying dimension, a single underlying dimension. And it's proven to be pretty good at this. Yeah. And then we have another category of traditional methods, which is known as supervised learning. And here we have algorithms like naive Bayes, k-nearest neighbors, decision trees, support vector machines, logistic regression, neural networks, and very often these are combined. Yeah, so you might use k-nearest neighbor with a logistic regression on top. Yeah. And your whole idea is that you basically want to classify texts into certain categories. Yeah. So you say like, I've got 20 categories and I want to figure out which text goes where. Yeah? And then the algorithm does that. And very often it's based on your own decision which of the algorithms work. Yeah. That's the supervised learning. Then we have unsupervised learning. This is where you do not yet have your categories ready. And a very good way to define that is that it's a class of methods that learn underlying features of text without explicitly imposing categories of interest, right? So, and therefore, rather than requiring us to condition on known categories, we can use modeling assumptions and properties of the text to find new categories. And this mostly comes in fully automated and computer-assisted clustering. The difference mostly is that in the latter, we help the computer, and in the first, we basically have the computer choose something, and we then figure out something on using lots of statistics, which one's good. For example, here, this is a case where we had tons and tons of documents from the Bulgarian parliament, basically debates, and we wanted to figure out what was going on. So we run a topic model, which is an unsupervised thing, which clusters this into lots of topics. And we just did a hierarchy of topics. And then we said like, okay, we cut it here to say like, okay, we've got like 9 topics to work with. Yeah, that's unsupervised. So you put it in and the computer comes back with a clustering. So that's what basically the kind of traditional methods were until like say 4 or 5 years ago. And you can still do that. And this is if you would go to summer school and you would go to the introduction to text analysis, that's what you will get. That's kind of where you will end, maybe a little further. What's been going on recently is mostly based around this idea of word embeddings. Now, the main trick and the main idea that word embeddings does, it gets rid of this traditional idea of the bag of words. This idea that we lose the context of the word. So context is the main idea here. So remember that if we have the bag of words, we basically get rid of a lot of information. Yeah? Because if you write yourself a document, the word order is pretty important. Yeah? And the bag of words get rid of that. Yeah? It's proven to be very good, but word embeddings don't have that idea. It has basically 3 IDs in there. Basically, what we do is that we use something that's known as self-supervision, in which we use metadata that comes with a text to provide association with the words. The second thing we do, and the most crucial one, is that we pay attention to the context of words in a certain window. So we say like, the meaning of a word is decided by the family it keeps, right? So the meaning of a word is decided by what words are around it. Yeah. So the idea is that a word is embedded in a certain context. Yeah. And that when humans, so we read a text, the meaning of a word is basically decided by the context it is in, right? So if we, for example, read that sentence above there, word embeddings depart from the traditional idea of the bag of words, we see that the word bag here is meant, as like an ID, not as an actual physical bag. That's clear from the sentence. And the third thing it basically based upon is that we reduce the dimensionality of the text, which is basically all the words as possible, using either singular value decomposition or principal component analysis, what you want, to create representations of words in a space. So we will get later how this works. So what we want to do is that we want to represent words as fixed dimensional factors in a continuous space. Yeah? If we have a text of, say, 100 words, then we have a potential 100-dimensional space. We want to limit that. Yeah? That's why we use singular value decomposition. And we therefore map each word to a single factor. And that we can do with lots of methods like word2vec or glow. There are lots of ways to do this. And then the relationship between the factors is the same as the semantic relationship between the words. Yeah? So that's based on co-occurrence in this large text corpora we have. So fixed factor representations for each word, and regardless of its context in the sentence is there. So how does this work? So you do this with singular value decomposition, and I took this very nice picture of good slides by Lynn Voita. You see the link down below. Please do check it out. So we basically do. So we have again this data frame that I showed you. So we have the words in the rows. And then the columns have potential context. So it's not a count over text like the traditional data frequency matrix, but it's the potential context that a word can be in. So for each word that we have the potential context to begin. So if we have 5 times the word fire engine, for example, we have 5 columns to say like which context does it occur in. Yeah? And then we're going to figure out if there's some way that we can reduce that dimensionality. Yeah? So we have word factors, and we have basically the context factors, and that's SVD. And this makes it way smaller, and we can actually work with it. Yeah? And again, singular value decomposition is the most popular way to do it because it happens to be very quick and quite accurate. But there are other ways if you want to. So this is the singular value decomposition. Let's skip over that for now. So why would we use these word embeddings? Now, the good thing about word embeddings is that they solve this issue of bag of words. The context is lost. This was one of the main complaints. So, I mean, I can remember when you talked about text analysis, the first thing people said, like, well, this bag of words just is a very, very, very heavy assumption. Am I actually willing to take that? Am I willing to throw away all that context? No, we don't have to. They encode similarity, and less information is thrown away. So we capture more of what's in that text. Yeah? And the context of the word helps us to figure out its meaning, which is apparently very, very practical in political cases, because in political cases, very, very often, a word has a meaning. There's lots of wordplay in there. There's politics in a text. So knowing the context is very, very relevant. For example, again, with numbers, for example, 4% has a way different meaning in the context of the EU than it might have in something like a tax-related thing in a country. Yeah, so that really is important. And these kind of things happen. Yeah. So have an idea that works. So one of the more popular examples is the picture you see here. So take, for example, the word awful. Because we can see how it is embedded, so we can see the context of the word. So if we have the word awful in the 1850s, it meant something like solemn and majestic, like an awful majesty. So it was actually a very powerful thing. Yeah. Lots of religious hymns had like an awful thing in there and meant something good. And then suddenly in the 1900s, we saw that the word used, the context of the word changed, right? So it started to mean horrible, appalling, and terrible. That's the context it has. And nowadays, it's even shifted in the 1990s. It goes towards this more weird, yeah? And that's the meaning it has. So it changed meaning over time. The same you could see, for example, with the word gay, which meant something like daft, flaunting, and tasteful. Then in the 1950s became a context of witty and bright, and nowadays it's in the context of homosexuality, bisexuality. So the word has a different context. It has different friends, to put it that way. And this is something that's very important to see. So we can see how that changes. That's what word embeddings do. And if you want some interest in it, um, then these are some very good papers that basically show the best of it. So one of the things, that if you're interested in this one, please have a look at the paper by Rodriguez and Sperling. Sperling is also the one that wrote that great paper about cleaning up your text and pre-processing it. And for a good example, there's a very recent paper about US congressional speeches where you can see a shift from evidence to intuition. So this is a very nice example of what you can actually study with these kind of things. So these are 4 things that are very good, but there are loads of things out there. Yeah, and as you can see, it's a very new thing. So 2019, Roland Cochrane, one of the first in there. So we're dealing with new things. So another thing, transformers. Now, transformers are one of the bigger things that's been going on there. So I will skip over that one, I'll come back. Transformers were introduced by this paper, and it was called Attention is All You Need. It's one of the highest cited papers I know. It's only an archive because computer scientists don't have to publish in journals. It's written by a couple of guys at Google, and I do not expect you to understand this. So what it basically did is that it revolutionized the way that we look at these kind of text. Yeah. So one of the differences is that word embeddings were seen as very nice, but a bit limited, because they gave static fixed factor representations for words. You know, once a word had a factor, that's where it will stay. Yeah? Transformers, however, contextualize it even more and are dynamic that consider word order and the surrounding context. So a word embedding did it word for word. This actually is able to put a whole sentence, and that's what the attention refers to. So it looks at a word and it pays attention to what's around it. Where in the text is it? Yeah, that's what it does. So transformers are models that capture contextual relationships in text using self-attention mechanisms. Yeah. And you might have heard some of them. So BERT is one of them, but GPT as well. ChatGPT is built basically on loads and loads of transformers bunched together. BERT is a very good one. Words are represented by context-dependent embeddings that vary based on surrounding words. So a word basically has a representation, and how it's represented depends on the context. Yeah. It's highly scalable. So one of the nicer things with it compared to word embeddings is that word embeddings tend to come very, 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 very big because each word is considered uniquely. This is very smart and can therefore actually be way quicker implemented. Takes less power in your computer. It can also handle variable length inputs and therefore provide richer representations for text, yeah, like classification. So it's very, very good in translation, summarization, these kind of things. This field has really exploded. So it's really got off in 2018. Were we in there? On the left here, you see these kind of things that look at the number of parameters. We're now in trillions. This stopped in 2023. There's different families in there which you might hear of, but you can mostly ignore them. For most of the science purposes, things like BERT, which you see that have been introduced in 2019, works really well. And these kind of transformers have to be trained, and they're mostly trained on huge data sets. So if you have BERT, for example, you could BERT model, that can take a long time to train. So what can we use it for? So transformers are also behind most LLMs, which we can use for all kinds of things like generate new texts. They're very good at text summarization, selecting key sentences. That's actually something we can use them. So we can put in lots of text and we can tell them like, okay, what are the key sentences of our text? They can do easy sentiment analysis without just having to put in a dictionary. So we can just select, oh, is this a happy sentence or a not happy one? Um, and they can do chatbots, etc. And a good case study, for example, is here this one on Qual, where people use LLMs to extract quantitative insight from online forums. Yeah, so how you can do that. And they are very, very good in putting loads of large unstructured data. So you don't structure like things like tweets, things that have different length, etc. Okay. Then I want to talk a little bit about multilingual because it's the last thing that's been a big change in the last years. So one of the things right now is that when you used to do with these traditional methods, you did something, you were limited to mostly a single language. Doing it in multiple languages was trouble because you had this data form and you would have different languages in the same, and you wouldn't know that the same word meant something in different languages. Yeah, so it was very hard. You could do it, but it was trouble. Nowadays, with multilingual pre-trained models like Ambert, XLMR, we can do analysis on multiple languages at the same time. And they can use shared embeddings. So we can have different documents in different languages, and the model can figure out whether certain words mean the same in different languages. Yeah? So we can, for example, have something about colors, and the model can figure out the Spanish word for red, rojo, is the same as red in English. Right? It can figure that out. And it can then actually use that to generate things. Yeah? Um, and then we can fine tune that for what we need. So languages you can also read as within English, different dialects or different ways of talking. We can select, okay, is there a difference between how, for example, like bureaucracy talks and people outside of it talk, these kind of things. And it has a very good use case. So it allows us to do these kind of things cross borders. We can easily scale up, so we don't need to train separate models. If we want, for example, to compare documents over Europe, we can just put it in one model. And it's very efficient in a certain way. However, this is one of the newer things that's going on. It's still very much in development. There's not a lot of papers out there. And the problem is that it's very resource intensive. These models are huge, require also a lot of training and crucially a lot of fine tuning. There is a lot of fiddling that needs to be going on before you actually can get it to work. They also require significant computational resources and make them quite expensive. And they're not always good with all kinds of models. So some languages, if there's more training data, they just perform better than if it's languages where for there's not a lot of training data. So they tend to be very good in languages like English or German and French, but they're way worse with languages like Finnish or Afrikaans, for example, if there's not a lot of data available. And they come with quite some biases and some data quality issues. And I will get to that a little bit later. And you can evaluate this. So you have with these kind of models, even more so than with the other ones that I presented earlier, you've got to figure out whether it's good. And there are a lot of different ways to do that, lots of evaluation metrics. Some of them are here, but you've got to do it to figure out how good your models are. So, having discussed that, I wanted to talk a little bit about various considerations that we should have when we do any kind of new text analysis thing. So, referring back to what I said in the beginning, when we do a text analysis, an advanced text analysis, it's important to realize that we do not assume, or we should not assume that there's a single model that captures a true data generating process, right? So there is nothing that's perfect. There's no model that fits it. We always lose something. But what we should basically figure out is what we need for our research question. So one of the things that you should not do is like, oh, this is a very cool method, I want to use it. Right? You should think from your research question and think like, okay, this is my question, what do I need? And it might be that you need something like very simple, like an old-fashioned dictionary analysis, if that's what you're needing. Yeah. So think in that way. And also remember that nothing beats actually understanding your data. Yeah. Nothing beats that. So very often what you see happening is that people choose a very fancy kind of data set, huge, but have no clue what's inside. Even worse with the model, some of the latest models are very nice, but have huge complication how it actually works. And you might end up taking a model that you do not understand. You should understand what's going on. You understand what the model does, why it does it, and what that actually implies for the results. Yeah, you should. It's not like just like, oh, I don't know why this comes out. You should know why it came out. And you should therefore focus on what each step of your analysis means. And this goes also very pre-processing. What happens when I do this? Yeah. So for each and every step in there, what it means. And finally, it's very important to keep things simple. It is very, very, it's very nice often to make a very complicated model and do this and this and this, but keep it simple. Stick to the point. If it works, it works. Yeah, keep it simple. Try to cut back on things that you don't need. And then something that didn't used to be that important, but nowadays really is. So with the rise of these LLMs, with these big embedding models that are trained by others, we've got some things to consider. And it's actually good that this is also considered if you do your normal texts. Some of them are bias and fairness. So one of the things that we see, for example, is that most of these models, embedding models, are trained on big internet data sets. And they tend to represent certain groups very, very well. So if you are a white, rich man from a well-developed country, you'll be well represented. If you're like, if you're not that, if you're like a woman in her 80s that lives in South Africa, you're probably not well represented. So there is bias in there. Second, biases from reality will be put again in the model. So it's not a value-free model. Yeah? It comes with opinions. It doesn't know that, but if I would train my model based on the internet, it comes with the biases that exist in real life. Yeah? And the model will just replicate that. Yeah? So that's in there. Representation in LLMs, like I said, some languages, some groups are simply underrepresented. So if you use it to study that group, you might be in trouble. Yeah. So if you use an LLM or these kind of like multilingual things to actually study, for example, underrepresented groups, you might get bad results because they are underrepresented and not these models. Then there is the even worse problem of transparency and accountability, because these things are mostly trained by huge companies and they don't tell you what data they use, how they train it, who trains it, how they got the data. So you don't know that. Yeah. So you get a little of a black box. All the traditional methods I mentioned are completely open. You know how they work. You can actually check the algorithm. You know the data goes in, you know what goes out. Here's not the case. It's a bit of a black box. So also there's political and economical leaning. That's quite obvious. That comes with the biases that are in society. They're basically put in, which is a trouble if you, as a political scientist, for example, want to measure something. So you don't only have the political bias that comes in your data, but also the one that's inherent to the model. Then also you need lots of training time. Yeah, these things need to run somewhere on a big computer. And you kind of need some technical skills. These kind of LLMs, you can't learn that in a week. You need to know some computing, you need some programming, you need some skills in there. And also, then there is the idea of interpretability. Sometimes it comes out with outcomes that make no sense. And you can't always explain why something is the way it is, right? So because it's a little bit of a black box. And then there's also data protection and privacy laws. That's another issue. Because the data that you mostly put in these models sometimes goes uploaded to a server, and you might have all kind of privacy issues that are important there. So I wanted to end with six considerations for text analysis that I think are important here, and they come from a book called Text as Data by Stuart Graham and Roberts in 2022, which I personally consider the main foundation for most data analysis in social sciences. It's built on lots of work that those authors did. There is a good paper by Graham and Stewart from 2013, from which there's lots of figures that I show mostly. And one of the reasons I think is that they wrote this like text as data for social scientists. And basically, one thing I noticed is that you cannot do any text analysis without any substantial theory or knowledge. Yeah? You can't just like, okay, let's put it in there. You have to have some sort of theory. You need to know what's going on. Yeah? You're testing a theory. You're testing something. You have some assumptions about it, and you need to know the field. You can't just study a field. So I can't just like, okay, I'm going to study needle workers in Bangladesh. I should know something about these people. Yeah, I should know something about that field. Second, text analysis augments humans, not replace them. There will always be a human in the loop. Yeah, computers make our life easier, but in the end, we write stuff for humans. Yeah? So they help us to do it, not replace us. And we can't blame the computer like, oh, the computer did it. No, no, no. We did it, and we just used the computer. Then building and refining and testing social science theories requires iteration and accumulation, also text analysis. Very rarely it happens that you have got the right methods from the get-go. You mostly do it, test it, does it work? No. Let's go back. Let's iterate. Let's accumulate, and then you find what you want. Then text analysis methods distill generalizations from language. So whatever we do, we always lose something. Yeah. And we are just wanting to know something like, we've got this big course of text. What is it about? We have questions about it. We want to ask that text some questions. And the best method, therefore, depends on the task, like I said. So and the task, what is your task? What's your question? What do you want? And by that, you chose the method. And finally, validate, validate, validate. This is how it was written in the earlier paper, but I put it a little bit nicer. But validation is essential because in the end, this is a computer that just counts. And you need to validate whether or not your results make any actual sense. Yeah? Validation is very, very important. And that is what I wanted to share with you. Thanks very much. I hope this gave an idea of the recent advances. This is what the ones I see, I think, are important. If you go to the summer school, this is what we will mostly cover in the advanced quantitative text analysis course. If you're more interested in the ones that I showed in the beginning, there's the intro to quantitative text analysis course in 2 weeks. That's in there. And in the first week, you'll have these traditional methods, the cleaning, and anything up till supervised and unsupervised methods. And in the second week, we go into the advanced ones, we go into the word embeddings, we go into the multilingual LLMs. And that's it. Thank you very much. Yes, as you can see, the link to the summer school has been there. And yeah, that's it from my side. Thanks. And I think there should be, I don't know if there are questions, if I can see them. Let me see. Could I? Wait, I can. No, there's no questions. So then, if that's all, then I want to thank you very much for joining me, and maybe see you at the summer school.